Hey guys, I'm back with a new video. In this video, we'll start with a new series, and this is the most requested series from my viewers, and in this series, we will be solving problems on data structures. So in the very first video of this series, we will first understand the basics of the language that we will be using for solving problems on data structures. I will be using Java programming language for solving problems on data structures, though you can use any language of your choice. Whatever language you use, only the syntax will differ. The main focus is to build logical and problem solving skills for solving problems on this topic. So without wasting any time, let us go over the basics of the language in this video, and then we will start with our main topic in the very next one. Let me give a brief overview of the language, and then we will see how we can write Java code. Now, Java is a programming language that is one of the most popular and widely used languages. Just like C++, Java is an object-oriented programming language, and it embraces objects to define real-world entities. The Java code that you and I write in the editor gets first compiled into the bytecode, which is machine independent, and then this bytecode is made to run on a Java virtual machine independent of the underlying architecture. Next, the Java code is always written in the form of classes and objects. Let us write a simple hello world program first before we understand more programming constructs that we would require in this series. If you want to use some other language for this series, feel free to skip this lesson and check the next video. So let us write our hello world program. So as I already told you that Java code uses classes and objects. So first, right inside my hello world.java file, let us define a class by saying public class hello world. Let me zoom this up. So here you can see that we are prepending the class keyword with the public access modifier, which means that the class is accessible from outside, and you can also inherit all the functionalities defined right inside the class if you need to. Also, the name of the file and the class must match. So hello world and the name of the file is also hello world. Now right inside the class, we need to define the main function. Let us define that. So public static void main string array args, and then let us print hello world to the terminal. So for that we can say system.out.println hello world, like this. Now this main function is the driver code. Once you run your Java code, this main function is the first thing that will get executed, and then it will print the message hello world to the terminal. So for running this example, you first need to install Java onto your system and the Java JDK, and then in the current folder that you are working in, execute these commands. So you can compile the code by saying java c hello world.java. So compilation is done. To run the file, you have to say java hello world, and you can see we are getting the output hello world logged to our terminal. Let us first understand about variables in Java. So variables, and let us comment this out. So a variable is simply a container that holds some value. Now in order to define a variable, we first need to specify the data type of the variable. Like if I want to define age, which is a number, we can say int, which is the data type, then the variable name, and set that to some value. So let us set this to 23. So here we have the data type, then the variable name, and the value that you want to set to this variable. Now let us print the age to the terminal. So for printing the age to the terminal, let us say system.out.println the age is. So here we are concatenating the string with this age variable. So let us run the file to see what we get. Java c hello world.java to compile the file. And now in order to run the file, you can say java hello world like this, and you can see we are getting the age is 23. Now I told you that this is a string, so let us understand a bit about strings. We will see them in later videos and the problems related to it. Now in order to define a string, we can make use of the string class, and then the name of the variable in which you want to store the string, say channel. Now as we know that string is a sequence of characters that you wrap under double quotes like this. And for now, just understand this much. We will see strings in great depth in a later video. So let us set this to the nerdy div. And let us print the channel to the terminal. So system.out.println channel. So let us again run the file. by first compiling this and then running it. So here we are getting the nerdy div as the output. Now let me tell you a bit about the operations that you can perform on numbers. For example, apart from the normal add, subtract, divide, multiply, exponentiation operations, we can increment, decrement a number by a certain factor. So let us increment the h variable by 1. So for that, let us say h plus 1, and let us again print the h to the terminal. So I'll paste this out here, and let us again compile our code and run the file. So you can see now the age is 24 because we incremented the age right here. So 23 got incremented by 1. So now the age is 24, and now we are getting the age is 24 logged to the terminal. Now you could also say age plus plus instead of this. So age plus plus, and if we again compile the code and run the file, you still get the same output. The age is 24. So this is a shorthand notation for this, so you can use either one of them. Now let us increment the age by a certain factor. Let us increment the age by 2. So age plus equal 2 like this, and let us again print the age to the terminal and run the file. So first compile and then run. Now the age becomes 26. So at this point we are having age as 24. Then we incremented the age by a factor of 2, so 24 plus 2, and the age is now 26. Now we can also decrement our integer data, so let us do that. So for that I can say age minus equal to, say by a factor of 2 again, and let us print the age again, compile our code and run the file. So now the age again becomes 24, because at this point we are having age as 26. We decremented it by 2, and now the age is 24. So let us move forward and see some basics on strings that we would be requiring in this series. Now just a while back we defined a string and set that to some value. Now let me show you a method that you can use on the string to access a character sitting at a certain index. To access a character sitting at index 2, for example, let us use the caret method. So system.out.println channel dot character that is sitting at the index say 2, and now let us run the file by first compiling it and then running it. So now you can see the character that is sitting at the index 2 for this string is E, because the indexing in programming languages generally starts from an index of 0. So this is 0, the character at index 1 is H, and the character at index 2 is small e. So that is why we are getting small e being locked to a terminal. Now let us see how we can convert the string to its uppercase version. So that is very simple. So we can say system.out.println channel.toUppercase like this. So this is a method as well, just like the caret method, and you are using them on the string. So let us run the file to see what we get. And you can see we are getting the string in all uppercase version. Now to convert the string to its lowercase version, we have the method toLowercase. So let us copy this and paste it down below and change this to toLowercase. Again run the file, and you can see the string is getting locked in its complete lowercase version. Now this was just the basics that I wanted to cover about strings in this video. We will see more on strings in a separate video. Let us move on to arrays now, but before that, let us understand a bit about conditional statements that you must be aware of from other programming languages. To check for a certain condition, we can make use of the if statement. So, conditional statements. Now let us define a condition that if the age of the person is greater than or equal to 23, then we log something to the terminal, else we log something else to the terminal. So for that, we can say if the age of the person is greater than or equal to 23, then let us log to the terminal that your age is greater than or equal to 23. Else if the condition doesn't hold true, then let us print you are less than 23 years old. Now let us run the file to see what we get. So you can see, because our age is greater than or equal to 23, we are getting this message being logged to our terminal. So let us keep it simple for now, just to recall the programming constructs that you must know before watching this series. Now let us move forward with arrays. Now what is an array? An array, as we know, is a collection of homogeneous elements of same type that are referred by a common name. In Java, all the arrays are dynamically allocated. Let us see how we can declare an array. So let us define an array of numbers. So the syntax for defining an array looks something like this: int, and then we use the square braces to denote that we are defining an array, and then the name of the variable, set that to a pair of curly braces, and then the elements that you want in this array. So 1, 2, 3, 4, 5, 6, 7, 8. Now one thing that we can do over such a collection of elements is that we can iterate over them. So let us use a Java for loop to iterate over this array of numbers. So let us define a loop. So for int I as 0, and then we need to define the condition that the loop must hold. So here we are defining the initial value of our temporary variable. Then you need to define the condition that each element of your array should hold. So I, the index, should be less than numbers.length, and then you need to increment the index, the temporary variable, which you are using to iterate over this list of numbers, by 1. So let us print the number to the terminal. So to access the number, first you need to use the name of the variable which is storing an array, which is numbers, and to refer the element that you are currently on, you can use the square brace notation and pass the index like this. So our index is I, so for the very first element, I will be 0, so number 0 will be 1, and you are logging 1 to the terminal because 0 is less than the number's length. That is true. So that is why we were able to enter the for loop. Now once you print 1 to the terminal, I will get incremented by 1. Now I becomes 1. Now 1 is less than 8, which is the number's length. Again you print an element to the terminal, which is 2 in this case. Then you increment I by 1. So now I becomes 2, and 2 is less than 8. The condition still holds true. Now the element that is sitting at index 2 is 3. So you print that to the terminal, and that is how you will print the entire list of numbers. Now you can see that 8 is sitting at an index 7, and 7 is less than numbers.length, which is 8. So you will print 8 as well. Now comes the ending of the loop because I will get incremented by 1, so it becomes 8. Now if we again test the condition 8 less than 8, which is false, because now we have no more elements to print, we will come out of this loop. So let us run the file to see the output, and you can see we are getting all elements of our list being logged to the terminal. So let us print them in a single line by using the print method instead of the println method, and let us give some space between all the elements that are being printed to the terminal like this. Run the file. Okay, so this looks a bit cleaner. So let us leave a line after printing this list of numbers. So let us say system.out.println by using the println method. Now we can also instantiate an array in Java using the new keyword. You can explicitly mention the size that you want for your array. So let us declare an array of names, as we know that name is a string. So we need an array of strings. So to define an array of strings, first need to tell the type of the variable, which is a string. So we have to use the string class here, then the square braces to indicate that it is an array, and then names, and then use the new keyword. Again use the class, and we want an array of strings, an array of names. So we want an array of 4 names. And now let us add some values to the array of strings that we just defined. So names, use the index 0 to refer to the first element, and let us add Alex there. Names 1 to refer to the second element, James, and let us complete this. So names 2, Danny, and names 3, Mark. And finally let us iterate over the array of strings using the for loop. So for int I as 0, I less than names.length, I plus plus, and to print each element, use the print method. To refer the current element, you can say names I and some space to render them in a single line, just like this. So let us run the file, and you can see we are getting all the names being logged to the terminal: Alex, James, Danny, and Mark. Now we do have other loops like while loop, do while loop, that you can use in Java. And if you are familiar with any programming language, especially C++ or JavaScript, then you must be knowing about them. So let us move forward with another traversal technique, which is same as our for loop, and this is known as a foreach loop. So let us print a line first. Now to iterate over the numbers array that we defined above using a for each loop, let us try this. So for int number, which in each iteration will refer the current element, colon the collection on which you are iterating, which is the numbers array, and then let us print the number to the terminal. So system.out.print number. Now here we are not using any index, so to refer the element that you are currently on in the collection, you can just use the temporary variable that we are defining right here, and each time you will print the element to the terminal, and under the hood it is maintaining an iterator to basically go over the collection of numbers and print them to the terminal. So the increment of the index is going under the hood, and that is not visible to us right here. So this is some abstraction that for each loop uses. And let us give some space here to print it in a pretty format. Let us compile the code and run the file. And you can see we are getting the same output being logged to the terminal, and we can do the same thing for our array of strings as well. So let us do this. So for string, because we know that name is a string, in the collection of strings, which is an array itself, and we can print the string like this. Let us again run the file, and let us leave a line here as well. So let me copy this and paste it. So we are getting the same output again. So you can see this works as expected. So now we learned about conditional statements a while back. Let us talk a little bit about jump statements, which you should have a good hold of because you may need to use them based on certain conditions. Now you can use a break keyword in order to exit from a loop based on some condition. For example, the break keyword forces immediate termination of a loop by passing any remaining code in the body of the for loop. Now in case of nested loops where one loop is present within the scope of another loop, if you use a break statement within the inner loop, then it only breaks out from that inner loop. So do take a note of that as well. So let us see a simple for loop and understand the concept of the break keyword. So the jump statements, first the break keyword. So let us define a simple for loop and run this 10 times from 0 to 9. So for int I is 0, I less than 10 and I plus plus, and let us print. So system.out.print I is, let's put a colon and then concatenate I like this. And now let us define a condition at which we want to break. So if I is 7, let us break out from the for loop. So each time you are going over numbers from 0 to 9, and as soon as you reach a numerical value of 7, you terminate from the for loop using the break keyword. And once you break out of the for loop, the numbers from 7 and onwards will not get logged to the terminal. So let us run the file to see what we get, and let us leave a line here as well. So let us compile the code and run this. So here we need to print as a line. Let us compile it and run again. So you can see the code did run, and we logged all the I values from 0 to 6. Now once I becomes 7, you break out of the for loop and 7 does not get printed to the terminal. So once you are outside the loop is done, and then all the code that is defined right after the for loop will start executing. Now let us learn about another jump statement, and that is the continue keyword. And what this continue keyword does is that it abandons the current iteration based on some condition. So if the condition comes out to be true, it skips and continue with the next iteration, and all the remaining code of the current iteration below the continue keyword doesn't get executed at all. So let us see an example of this to understand it in more detail. So let us again generate numbers from 0 to 9, and what I now want is that if the number that we are currently on is an even number, skip and continue in that case, which means that if the current number is an even number, then you start the next iteration without finishing the current iteration, right? So let us see this in action. So continue keyword, and let us copy the above code and paste it down below, and let us check here for the even case. So if the number is even, which you can check by saying I modulo 2 is equals to 0. So if this condition holds, we can use the continue keyword here. That is, whenever you get an even number, just abandon the current iteration. So don't print this thing and move forward to the next iteration. So what output do you expect? So let us run the file to see what we get. And you can see that we are getting all the odd numbers in this case. Because for each even number, we are skipping the current iteration. And that is why all the even numbers will not get logged to the terminal. And hence, we are getting 1, 3, 5, 7, and 9 being logged to the terminal. Now let us talk about the concept of type conversion in Java with some examples. Now when you assign a value of one type, of one data type to another, the two types might not be compatible with one another. Now if the types are compatible with each other, then what Java does is that it performs implicit type conversion for us under the hood, and if the types are not compatible with each other, then they need to be explicitly converted or explicitly casted, and this is known as typecasting. Now let us see some examples in action. Let us define an integer variable, so int a, and set that to 134. Now for implicit type conversion, let us take an example where Java will convert an integer data type, so a value of smaller data type, to a long integer type data, which is the value of larger data type. So for that, let us define a variable of long data type, so long b, and set that to a. So here we are implicitly converting a value of smaller data type to a value of larger data type. And this conversion is possible because the types int and long are compatible with each other. So let us print both a and b to the terminal and run the file. So system.out.println and then system.out.println integer. So let us print a here and then long, and let us print b here, and let us run the file to see what we get. Now here you can see we are getting 134 for both the outputs. But there is a difference. Here any variable having an int data type takes 4 bytes of memory, whereas a variable having a long data type takes 8 bytes of memory. So let us understand a bit about explicit type conversion now. Let us define a double number which takes on decimal point values as well. So double C, and set that to 3212.21. Now in order to narrow down this double to an integer, we can use explicit type conversion to convert this to an integer. So let us do that. Int d, let us assign c to it, and let us narrow the type of c to an integer. So for that, we can use explicit type conversion like this. So a pair of parentheses, and then specify the type of the lower data type or the smaller data type that you want c to typecast to. So I want to cast c to an integer. So here we can say integer, and let us print d to the terminal and run the file. And you can see this is how we do type conversion, and this might come handy in some problems. So this was all about the video on basics of Java programming language. We will see more concepts in action, and I will explain them when we go over them. Let me know if you want a complete series on Java in the comment section as well. From the next video onwards, we'll start to solve problems. We'll also understand about more data structures like arrays, linked lists, array lists, strings, stacks, queues, trees, and more. So if you liked the video, do give it a thumbs up, subscribe to the channel, hit the bell icon to get the notification for all the upcoming uploads, and I will see you guys in the very next one.